Hey Blender artists, how's it going? This is the second video of the video series on making water simulations in Blender 2.8. Now I am working in a beta version of the software, so some of these may turn out to be outdated when the stable build of 2.8 comes out. However, this is correct as of December 28th, 2018. In this video, we'll go over the most obviously important physics aspect of the water itself. This is not exactly resolution, or resolution sort of more the calculation side. By the way, if you missed the video on resolution, go back to the first video. I'll put a link like up here somewhere. So you can go and watch that. It goes over the basics of water simulation in Blender and resolution and explains what that's all about. So it's pretty important. Go check it out. Now, so again, I'm going over the most important physics attribute of water in this video, which is viscosity. Now, viscosity is the measure of how slowly a water flows, or a liquid flows. Sorry, it might not be water. So the higher the viscosity, the slower it flows. The lower the viscosity, the faster it flows, and the more it's likely to splash. So here's a video of a very viscous liquid. This is a very high viscosity. You can see it doesn't even really flow, it kind of oozes. And then this is a video of a very low viscosity water. You can see it splashes, it goes all crazy, and it flows out. You can see it flows out a lot more across the floor there. Now, if you're wondering why it kind of splashes up against nothing on the edges, you can see it's hitting the air there. That's because of how the domain object was set up, which again is explained in the first video. Go back, check it out. So this is low viscosity flowing slowly, and this is high viscosity flowing slowly, and this is low viscosity flowing quickly. So viscosity is measured in scientific notation, which is the base times 10 to the power of the exponent, or the basic one is 1 times 10 to the power of 1. That would be 10. Now, viscosity of 10 would be incredibly slow. It's probably like glass. But that doesn't really matter. I'm not going to get into that. Now, let's hop over into Blender. Sorry, let me just open a new file there. And also, if the color I'll just change. Sorry about that. I have a program that will lower the color temperature of my screen so that it doesn't keep me up. I'm doing this kind of late at night, so not very late. It's like 9 o'clock. Anyway, so just open up a new Blender file and scale the default cube kind of bigger, and then go to the physics object, or physics. It's this little, I think that's probably supposed to be a planet with the moon orbiting it. I really hope to add color. I think you can change this in the theme. I haven't done that yet. I probably should. But at the same time, I want to leave the default for when I make tutorials. Anyway, so you add a fluid attribute. Give it type domain. Darn it. Hold on a second. Yeah, okay, so ignore this. This is going to be there. Ignore that. Sorry, that shouldn't happen. I was practicing the tutorial earlier, and there we go. No, wait, I don't want to do that. Here, I'll do that. There. I was practicing the tutorial earlier, and I baked something, and then the baking is stuck. So anyway, viscosity is down very much at the bottom. And so you have the base, and that's a decimal slider, so you can input your own very precise number, and then the exponent only accepts integers. So even if you put in 5.5, it rounds it up to 6. So if you put 5.4, it'll go back down to 5. So anything you put in there will round off. Now, one thing to note is that the exponent here is negative. So this right here is actually 5.65675 times 10 to the power of negative 5. It's not 10 to the power of 5, it's 10 to the power of negative 5. Blender just makes it like that. I don't know why. I think they should do it the other way. I don't really understand. I think it probably just makes it a little bit more user accessible. Frankly, I think it makes it more annoying because the higher this number is, then the lower the viscosity becomes. But that's the way it is. Anyway. Sorry, gotta stay hydrated. So, a higher exponent actually leads to a lower exponent, which leads to a smaller number, which then will have a lower viscosity and flow faster. A low exponent will lead to a high viscosity and it will flow slowly. A high base will lead to a higher viscosity and a slow flow, and a low base will lead to a low viscosity and a high flow. So yeah, that is the that's viscosity in Blender. You have the controls down here. They're at the very bottom of the physics tab under fluid type domain. It's always on the domain object. If you make a source object, you won't see the fluid in there. You have to make, you can only have one kind of fluid at a time in Blender. So yeah, if you like this video, drop a like. If you want, you can even subscribe. I don't really care, but you know, it'd be cool. Definitely go check out video number 1. It's very useful, I think. But yeah. Also, let me know what you thought in the comments about the different kinds of tutorials. This is more of a one take. Last one was more edited. And as such, there were some more like screen jumps and that kind of thing. Let me know what you thought. So yeah. Keep creating, keep doing Blender stuff. You guys are great. And have an excellent day.